This is Mission Control Houston. The space station itself has hundreds of experiments going on board at any one point in time during these expeditions. But did you know that there's an experiment on board that takes a look at a special classification of water? Because water sometimes can be neither a solid, liquid, or a gas. Here to explain this way better than I can is Michael Hicks, who's from NASA's Glenn Research Center. He is the principal investigator for what's called the Supercritical Water Mixture experiment. Mr. Hicks, thank you very much for joining us. First of all, let's talk about what supercritical water actually is.
Hi. Let me just first start with maybe somewhat of an unsatisfying answer, but simple, in that supercritical water is simply water that's taking past its critical point. And for water, the critical point is 374 degrees Celsius, or 705 degrees Fahrenheit. And its pressure is 218 atmosphere, which would be a little over 3,000 psi absolute. So that's supercritical water when it's taken past its critical point. And probably to give you a little more insight into the experiment itself, it might be good if I created a visual. If you could imagine taking a pot of water, and we put that, we fill that pot of water with maybe about a quarter full, and we put a lid on it, and we heated it up. The pressure would build up, and the pressure would not build up as fast as the temperature would, and eventually you would develop a vapor, which would then turn to a gas once you pass the critical point. And then when you compress that gas further, it would go into the supercritical range. And we have the same thing on the other side. If we filled up the pot with, let's say, 50% water, then you would increase if you heated it up and increased the pressure would build up. Eventually, the pot would fill with water, and because the pressure would condense whatever vapor was in there, and you would then cross over into the supercritical range. But the problem with that is that you really wouldn't be able to see exactly when you crossed over to the supercritical regime, because the pot in those instances would be filled either completely with vapor or completely with liquid, just because of the nature of where we started at. But with our experiment, what we try to do is we try to maintain the vapor in the presence of liquid throughout the heat-up period. So as we're heating up this pot of water, we actually have two phases, the vapor phase and the liquid phase, all the way up through the critical point. And in order to do that, you have to fill this pot of water with exactly the proper amount of vapor and liquid. And so that's roughly about 1/3 liquid and 2/3 vapor. And at that point, then you cross right through the critical point, and you can actually visually determine when you get to the critical point by looking at the disappearance of the separation between the vapor and the liquid, which would be the meniscus. So that, in essence, is the experiment that was performed about 4 years ago by our French colleagues. And what we are doing now with the supercritical water mixture experiment is we put a small pinch of salt in this water. We're actually using sodium sulfate, and we put that in solution, and we then heat it up. We then cross the critical point, and we're looking at when this critical point shifts, because our critical point will change a little bit because of the presence of the salt in the water. So that, in essence, in a nutshell, is the experiment that we're performing.
Okay, let's talk about real-world applications for this. The way I understand it is that there's actually some cities and some Navy ships that are kind of using the supercritical water to sort of clean waste and things like that. Talk about real-world examples of what this does for people on Earth.
Yeah, one of the great advantages of supercritical water is that it becomes a terrific solvent for organic material, organic waste. And this is because of this change in material properties or thermophysical properties when it goes into its supercritical regime. And so there's a facility that's in Orlando, Florida, that was just put online not too long ago. The city of Orlando uses supercritical water oxidation technology to basically convert all their waste to either they essentially burn their waste in a supercritical water reactor, and the byproducts are then carbon dioxide and water. So it's a relatively benign product stream once they take this supercritical water waste stream and oxidize it.
So what's next? I hear that you guys have another run of this experiment coming up, I think in March, maybe, or whenever it's going to be. So what are the next steps?
Well, the next step would be to basically repeat the test that we had already done in July, and that's coming up in March. And so March 3rd, we're scheduled for an 18-day test sequence, and we'll have another test sequence after that, probably in April. So starting in March, we'll become busy again with this experiment.
All right. Michael Hicks from NASA's Glenn Research Center, thank you very much for joining us here on Space Station Live.
You're welcome. Thank you for your interest.
Thank you. Again, that is the Supercritical Water Mixture experiment. Of course, you can read more about that on nasa.gov/station. Just take a look at research and technology there on the left-hand side, and you can look up pretty much anything that these expedition crews are working on a day-to-day basis, or you can look up the science in alphabetical order.